Hey, James. I am not going to do problem 4 from section 4 because I think if you look at that, you just made a careless mistake on that one. But you can take another look at problem 4. The correct answer, I think, it was 1:40 in the afternoon. I'm going to do set problems 10 and 11, even though I think you got 10 right. You circled it, so maybe you had a question on it. So this is a science-related pair of problems. They told us in the big long blah lead up to the problem that we have the formula weight equals mass times acceleration due to gravity. And in problem 10, it says, what is the weight in newtons of an object on Mercury with a mass of 90 kilograms? So I know the mass is 90, and I can look at the chart, again in the prelude to the problem, and acceleration due to gravity on Mercury is 3.6. And so that's just a plug in the numbers in the right place. And if you multiply 3.6 times 90, you get 324. We don't really care about the units that much. It's just putting the numbers into the right place. Problem 11 is a little harder, but it's not that brutal. So now we're still using that same formula, weight equals mass times gravitational acceleration. And an object on Earth has a weight, so that's the weight is 150. And on which planet would the same object have an approximate weight of 170 newtons? So if we know that the weight is 150 on Earth, we can plug in the gravitational acceleration, which is given in the table, and the only thing we don't know is what the mass is. Now it's helpful, it's not entirely necessary, but it's helpful to know that the mass is constant, although the weight changes depending on where you are, what planet you're on. But so now we've solved for the mass. The mass is 15.3. We can plug that into the problem. So we know that we have a mass of 15.3. We know the weight is 170. And all we are left to find out is gravitational acceleration. And if we divide 170 by 15.3, it's about 11.1. And that is, if we look on the table, the planet that has a gravitational acceleration of approximately 11.1 is Saturn. I think I'm going to try to do one more on this page. I can only do these videos for 6 or 7 minutes, and then they cut off. All right, the next one you got wrong was 13. And 13, again, this is a sort of science-related one. But it doesn't matter. It's not like you're really just plugging in stuff into the formula that they gave us. Oops. Well, this is what's called sometimes called a literal equation because it's got a whole bunch of letters in it. Sometimes people get the right answer, but it doesn't match with the answers given. That may have been a problem for you. Let's see. So I don't know, but I'm going to go ahead and solve this. It says basically it's saying what's V in terms of H, T, and K. And that means we want to get V by itself. And on the other side of the equation, we expect to see a bunch of junk, including H, T, and K. So it's really not that hard. I'm going to say I need to get this term by itself first. So I'm going to move this guy and this guy over to the other side of the equation. And that's going to give me, well, I'm also flipping the sides, but it's going to give me Vt equals H plus 16t squared minus k. And the only thing left to do now, we just are supposed to get v by itself, and v is being multiplied by t, so we want to divide both sides by t, and I'm going to get v equals all this junk over t. Now, it didn't seem like we did anything wrong there, but it doesn't match any of the answer choices. So how could we mess with this thing and get this answer into a different form? We could go ahead and do that division. I could really think of this as h divided by t, and this divided by t, and this divided by t, but the correct answer, if you look for it, is h minus k over t plus 16t, because one of the t's canceled up there. Okay, I think I'm going to stop the video there, and then I'll send you more. Okay, thanks, James.